Okay, so a little bit of review from our homework. Homework 14, this is number 21. Two plus 5 over x plus 1 over 5 equals 9 over 4x. Looking at this, since our variables, or there are variables that appear on the bottom of the fraction, it doesn't even have to be all of them. If there are any variables that appear on the bottom of a fraction, we have to do that least common denominator and get rid of the fractions. So for here, we have denominators of x, 5, and 4x. Bless you. We need to find a least common denominator for those. Well, for the numbers 5 and 4, what number would it be? 20. For the variables, remember, it's always the highest power of the variable. That would be just x. So 20x is our least common denominator, which means we're going to come back here and we're going to multiply this whole equation by 20x. So now we have 20x times 2, which is 40x. 20x times 5 over x, so the 20x over 1 times 5 over x. I am going to cheat just a touch and cross cancel the x's. So just 20 times 5 is 100. Now we have 20x, so I'm going to get 20x over 1 times 1/5. I'm just going to multiply it out. 20x times 1 is 20x. 1 times 5 is 5. Now 20x divided by 5 is just 4x. We hit the equal sign, so we put in our equal sign down here. And we have 20x times 9 over 4x. So 20x over 1 times 9 over 4x. And again, probably the easiest way to approach these is just multiply across. 20x times 9, 180x. 1 times 4x is 4x. Dividing out 180 divided by 4 is 45. 180 divided by 4 is 45. X divided by x cancels out. I'm going to stop there at this point. Anybody who really doesn't know where that came from? Okay. Now that we're at that point, we have an equation we can solve. So we've got 40x and 4x on the both sides of the equation, both on the same side of the equation, so we can combine them to get 44x. We have the plus 100 equals 45. Good. And then subtract 100. 44x equals a negative 55. And then we divide by 44. So x equals a negative 55 divided by 44, otherwise known as a negative 1.25. What's that? Yeah. That took me 4 minutes. Come on. So we'll take a look at number 20 here. So number 20, we got x plus 1/4 plus 1 equals 1/3 plus 1/9. Now here we could find a common denominator and multiply through by it if we wanted to. That would work. But we don't have to, because there's no variables on the bottom of those fractions. No, they're not. This one's got a denominator of 4, this got a denominator of 3, this got a denominator of 9. There's no variables in our denominators at all. Right? Unless I copied it down wrong. Nope, I didn't. So we can just deal with this as fractions. I mean, we could use a common denominator. That common denominator would be 36 for those of you following along at home. We could multiply by 36, but I think it's just going to make it more complicated. Here, we've got the 1/4 and the 1 that are on the same side. We can combine that. So that's x plus 1 1/4. We've added 1/4 plus 1 is 1 1/4. Over on this side, we have 1/3 and 1/9, which is going to give us 4/9 if we add them together. I'm going to leave it up to you to actually write out the fractions and do the addition, or use your calculator to add 1/3 plus 1/9. But you do get 4/9. Now that you have that, all we got to do is solve this equation, and the only step to solve that equation is to do what? Subtract 1 1/4. You got it. So x equals 4/9 minus 1 1/4 is negative 29/36. How many of you got to that? Cool. How many have no clue where that came from? Challenge accepted. Okay. So you said there was another homework assignment you wanted some problems from, or the other ones on this one, or?
What one is this? 14, right?
This is 14. Yeah.
Yeah, I was having issues with 13 too, I think.
Homework 13. We'll take a look.
Yeah. Oh, and I realized I can't do pre-algebra at 9 p.m.
Why not?
I have no idea, but apparently my brain is just done with this at that time.
So what are you looking at here?
Yeah, not that. Yeah, probably that.
Like that one?
Yeah.
Okay. That one's kind of fun. We'll do that one. Okay. Let's make sure I got everything here. Maybe I should have written smaller here. Okay, when we first look at this one, the first thing we see, of course, is there's parentheses. So let's look at each side of the equal sign here. Remember we said when you have all this extra stuff, you can split it into two problems at first. You find the equal sign. Then you can do everything on one side first. We'll do everything over here first. Now we have parentheses there, so if we go to that parentheses, is there anything to do inside that parentheses? No. Is there anything that needs to be done to the parentheses? Yeah, times 2. So that's going to make 2 times 3x is 6x. And then we can combine 3x and 6x make 9x. Negative 3 and 13 make positive 10. Over to the other side. We again see parentheses. So again, we have to ask, is there anything to do in those parentheses? Yes, there is. There's a couple of things we can do. What's 3 squared? 9. 9 minus 5 is then 4. So over here we have negative 3 minus 5x, and that's a positive 4, plus 4. Now we can combine. There's nothing we can combine with the negative 5x. But we can combine a negative 3 with a positive 4 to get positive 1. And then well, we have a variable on each side of the equation. The x appears on both sides. We have to get rid of 1. The smaller of the two is the negative 5x. We're going to get rid of it by Well, we could subtract a negative 5, or since that's negative, we could just add a positive 5. We'd make that 0, right? Negative 5x plus 5x is 0.
Right, yeah.
We should go away. Leaving us with just the positive 1, or just 1 over here. Over here, we have to add 5x. Or we could subtract a negative 5x, which is the same as adding 5x. 9x and 5x makes 14x. We still have the plus 10. Biggest mistake is a lot of people put that as 4x. Now what do we need to do? That's what you're doing?
Yeah.
Now what do we need to do? Add 10, or not add 10, but subtract 10. It's a positive 10, so we have to subtract 10. This is now negative 9, so 14x equals negative 9, and divide by 14. X equals negative 9/14. Negative 9/14. Well, what's it going to divide out to be? Negative 0. Negative 0.6428571426.
You didn't know that?
Doesn't convert to guessing at all.
Oh, come on.
Fractions, that's what-
Any other of those homework questions you want me to go over? Going once. Okay, we're shutting down the homework then. Let's get to our new stuff. Now that we've actually done some solving of these tougher equations, we can go to the next step. Doing word problems that require us to write these equations. For example, let's start with a simple little number problem, word problem. Let's say that you are told 5 times a number decreased by 2 is 38. We're starting out with this one because this is pretty straightforward. As I mentioned before, I think one of the most difficult, if not the most difficult things in math is taking words and putting them into an equation or formula. So here, one little clue we have, one key thing we have is the is here. That's usually your equal sign. So is 38 means something equals 38 here. So now on this side, let's put that together into symbols. How would we do that? 5 times a number decreased by 2 would be?
Why not?
5x. 5 times a number is 5x. Then decreased by 2 is minus 2.
But,
Why are there no parentheses?
Yeah.
The parentheses would be said 5 times the difference of a number and 2. When you word it that way, it means you've already subtracted, then you're multiplying the result of the subtraction by the 5.
So if you did
But when it says 5,
2 in parentheses, that's a whole different
that
thing.
would be wrong, yes. That would be very different. Because this is saying 5 times a number, then decreased by 2. And multiplication comes before subtraction in our order of operations. So this is 5 times the number, 5 times x, and then you decrease by 2.
Yeah, it's not reading it like that.
But if it said 5 times the difference of a number and 2, the difference is the result of a subtraction problem, which
Okay.
implies you've already subtracted. So that's where you add the parentheses.
Okay.
Now that we have the equation, how do we solve it? Add 2. So 5x equals 40. And then divide by 5. X equals 8. And you can go back to the original word problem if you want to and see if it works. 5 times a number, 5 times 8 is 40 decreased by 2 is 38. So it works. So we got another word problem, a little bit more complicated. I'd say that Betty makes $2 per hour more than Joe. In a week, where Joe worked 30 hours and Betty 35. Betty earns $110 more than Joe. Find the hourly wage for each. Where do we start? Well, we almost always start by what we're asked to find. We're asked to find for each Joe and Betty their hourly wage. Is there a relationship between the hourly wages? Remember, we can't have two variables. So we have to let one of them be our variable and the other one be something done to that variable. Is there a relationship? What's that say? She makes $2 an hour more. So which one of them do we want to let be X? Joe. If Joe is X, what's Betty? X plus 2, $2 per hour more. But we're not comparing their hours. We're comparing the dollars they earned. So we've got their dollars per hour. We actually have the number of hours given, which is 30 for Joe, 35 for Betty. So to get an expression for the amount of money they earned in that week, called their weekly gross, it is their number of hours times their wage. So 30 times X or X times 30, either one is just 30X. X plus 2 times 35 is just 35 times X plus 2. So the question is, what's the relationship between these? Do they add up to get a total? Do we have a total of their two? No, we don't. Remember, there's 3 possibilities in these problems. Possibility number 1. They add to a total. That's not the possibility here, is it? There's possibility number 2. Two things are equal to each other. In this case, are they equal to each other? No, they're not. Which means we're looking at possibility number 3, where they subtract to make a difference. So what that means, which one is bigger? Who earns more? Betty. So Betty's is bigger. So that means Betty's paycheck, 35 times X plus 2, minus Joe's paycheck, which is 30X. Has to equal the difference, which is 10. How are we doing so far? Wonderful.
Everything should be along this line.
So anyway, what do we have to do? We've got the parentheses, so we look there to see what we can do. There's nothing to do in the parentheses, but to the parentheses we have 35 times x makes 35x. 35 times 2 makes 70. Then we have minus 30x equals 110. And then,
What can you take from 30x?
yeah, we got 35x and negative 30x makes 5x. Then we have the plus 70 equals 110. And then, subtract 70. 5x equals 40. And then, divide by 5. X equals 8. All done?
No.
Why? What do we still need to do?
Well, what?
What do we still need to do?
I can't figure out how you got that.
Perfect. X equals 8. So we have to go back and answer the question. X represented Joe's wage, which was one of the things we were asked to find. Joe makes $8 an hour. But we're also asked to find Betty's wage, which is X plus 2. So 8 plus 2 makes 10. Betty makes $10 an hour.
Can you go up or down? Sorry.
Okay. What do we need to do here? Those two have to add up to 180. Very good. They add up to a total. So it's 3x minus 7 plus 5x plus 27 has to equal 180. Now we're going to go from there. What do we do? Combine. 3x and 5x make 8x. Then what? Negative 7 and 27 make it positive 20. Equals 180. Then what? Subtracting 20. X equals 160. And then divide by 8. X equals 20. Now, in this case, we didn't really ask a question. I mean, the question could have been find x. The question could have been find the angles. If that's the case, are we done? No, we have to go back and find the angles. So we put the 20 in here. 3 times 20 minus 7. Well, we have to do the 3 times 20 is 60 minus 7 is 53. Over here, I drew my picture way wrong, I know. I should have drawn a line that way. 5 times 20 plus 27. 5 plus 20 is 100. Plus 27 is 127. We can double check. Do those two add up to 180? Yes, they do. Okay. How about here? What's gonna happen? Anybody? Bueller? No, these two angles have to be equal to each other. Remember the vertical angles. So here and here, they have to be the same. So 5x minus 28 has to equal 3x plus 14. So now what? Subtract 3x. Very good. Get rid of the x's. So 2x minus 28 is 14. And then add 28. So 2x equals 42. And then divide by 2, x equals 21. All done? Well, possibly. If it asked for x, we would be. What if they asked for the angles? That would be 5 times 21 minus 28. 5 times 21, 25 minus 28 is 77. Double check over here, make sure we get the same. 3 times 21 plus 14. 3 times 21 is 63 plus 14 is 77. That's correct. This feels like a good point to take a break, so let's do that. We'll come back to about 20 after.